In today's video, I'll be introducing you to what has become one of the few standard products that we've developed at ILS. This is an example of an 8-fold parallel fixed bed unit. We deliver this in 4, 8, 12, and 16-fold versions, typically with 4 reactors and 1 temperature block. Flows can be independent, shared. Pressures can be independent or shared. This unit, as I said, is an 8-fold unit and has been specifically designed for green energy applications, covering everything from, you can do GTL applications like methanol synthesis, you can do Fischer-Tropsch in this unit, you can do ammonia synthesis in these types of units. This one is limited to 500 degrees. In a second option, we can crank that up to 1,000 degrees. In that case, we can look at things like ammonia cracking, dry reforming, or steam methane reforming. The heart of the system is basically this convection oven here, which contains our 2 reaction blocks. This unit has specifically been designed to also do FT, as I said before, and because in the case of FT, we have gas and liquid-based products, we have the ability here to remove the paraffinic products in the case of Fischer-Tropsch, which would be solid at room temperature, which is why they're located in the convection oven. We use these special throughput ports for the manual liquid removal. In the bottom here, we have a purged sampling system here so that the clients can access the glass vessels containing the wax, but purge it prior to opening them with nitrogen to make sure they're not exposed to any toxic synthesis gas components. Everything here has been mounted in one of our custom ovens. And basically what you'll see here is we have a series of gas liquid separators here. These have all been silicone-nerded in this case because the client wants to look at poisoning studies, and by working with the silicone nerd coatings, we can reduce the absorption coefficients for sulfurous or nitrogen-containing compounds, which are often used as poisons, and hence get more reproducible results. You have the 2 reaction blocks here. The reactors are removed from the top. In this case, the client wanted everything mounted in an enclosure. If for space reasons you don't have sufficient space for this, many laboratories that have good ventilation can operate this unit without the entire enclosure as shown here. The low temperature sampling vessels are located in this case on the outside here. Similar situation to what we have on the left for the high temperature ones, but in this case we've got cooled gas liquid separators here and at the bottom here. For example, in the case of Fischer-Tropsch, we'd be collecting the aqueous fraction here, which has some acids and alcohols in it. Or in the case of methanol synthesis, if we wanted to collect liquid fractions, we could do it here. But in methanol synthesis, in general, we typically do everything in the gas phase. One really nice thing about this design as well is all of these gas liquid separators have been designed with quick VCR connectors to be able to remove them. Hence, if the client is focusing, say, on ammonia synthesis or methanol synthesis, they can really reduce the dead volumes of the system by just easily pulling out all of the gas liquid separators and bypassing them. And if they ever decide to want to go back to something like FT work where you need to do liquid separation online, you can then easily put them back in place.